Good morning, students. Today we are going to study about generation of spectral lines in hydrogen spectrum. So before that, we need to understand the concept of transition of electrons from one state to one energy level to another energy level. So simply, when energy from outside source is applied to suppose hydrogen atom or any atom, so we can imagine it as it has a center called the nucleus and electrons revolve around it. When energy from outside source is applied, it absorbs a definite amount of energy and jumps to higher energy state. That means this electron jumps to a higher energy state. Excited state is, this is called ground state and this is called excited state. Usually ground state is the one which is very close to the nucleus. So excited state is usually unstable and electrons tends to come back to original ground state, which is lower energy level. With a jump, an energy is emitted in the form of a quantum, and in this transition energy is emitted. We already know about this concept from our previous knowledge. So it is emitted in the form of a quantum equal to difference in energy levels, which we have already discussed and is represented as del E equals to h nu, right? That means that's equals to E2 minus E1 from excited state, that is from second level to the first level. Energy, that means when n equals to 2 and n equals to 1. Electron is jumped from shell number 1 to shell number 2. Then we represent the difference in energy in the form of E2 minus E1. When this quantum of energy strikes the photographic plate, it gives its impression in the form of a line. So when we do the practicals, then it gives, we observe a spectral line. So similarly, not only the electrons will jump to the next energy level, it can also jump to another third energy level, suppose here, then again fourth level. So like that it will get excited and the electron will jump. So thus the different spectral lines in the spectrum is formed of atoms correspond to different transitions of electrons from higher energy levels to lower energy levels, because from higher energy level the electrons will try to get back to its lower energy level. So in this process it will emit certain energies in the form of quantum, and which in the photographic plate we see it as a line, that is called the spectral line. So it is easily shown here: ground state, excited state. So energy is released when it comes back from the excited to ground state. That means here energy is released. So similarly, if it goes to the third level, then also energy is released, and we represent it as E3 minus E1. So simultaneous appearance of a large number of spectral lines in the spectrum of hydrogen is observed. So this behavior is quite curious, and a question arises as to why hydrogen atom gives so many spectral lines although it contains only one electron. In fact, any sample of hydrogen gas contains a large number of atoms, and when energy is supplied by passing electric discharge, the electrons in different hydrogen atoms absorb different amounts of energies. Therefore, these are raised to different energy states. For example, the electron in some atoms may jump to second energy level, that means n equals to 2, while in others it may be raised to third energy level, n equals to 3, that means m shell. So similarly to n, then o, and then so on, and electrons then comes back to the lower energy level. So this phenomenon we will explain now, we will understand in details. So some of the electrons may jump directly to ground state from here. Suppose from fifth to ground state n equals to 1. Others may jump to second level and then to first, while some others may first drop to third state, then finally to first step. Like that the process will happen. These 4 routes are shown in this figure. So from the figure we can say that, for example, when the electron jumps from the energy level higher than the 1, suppose that is n equals to 2, 3, 4, 5 and so on, to energy level 1, the lines obtained in the ultraviolet region, these lines are obtained in the ultraviolet region, and this is called Lyman series. When it is jumped from any of these lines, from n equals to 5, 4, 3, 2, 1 to n equals to 1, when the electrons try to jump, then we get a Lyman series of spectrum. Similarly, the lines obtained when the electron jumps to second level from higher energy level, then we get the Balmer series. Then similarly to third energy level, then we get the Paschen series, then Brackett, then Pfund series. So this is the trend we have to remember. From any energy state to n equals to 1 energy level, then Lyman series, n equals to 2, then Balmer series. If it jumps to the third shell, then it is Paschen series, then fourth shell, then it is Brackett and Pfund series. So this is what is all about the series that we have to remember. And Bohr's theory helped basically in calculating the energy of the electron in a particular orbit of hydrogen atom. So thank you.